All right, good morning. Today we are continuing on with rules of exponents, and today we are putting it all together. So we're going to take a look at problems that involve the product rule, the power rule, the quotient rule, and the zero exponent rule, and even our negative exponent rules. So we're putting it all together, and in some cases, all in one problem. Now, before we get started, let's go over and kind of review the rules of exponents for the day. So if you take a look, and this is kind of the way that this was covered content-wise within the course as well. So if you look back through your notes, you'll be able to kind of probably find these rules actually in the order in which they're listed on this sheet. So let's take a look at rule number 1. If you are multiplying the same base with exponents, then we want to think about what you do. You keep the base and we add the exponents. So let's take a look at an example. If you have x to the second times x to the third, you want to think about what does that mean, right? That means you have x times x for the x squared. X cubed is 3 of those x's, and so therefore it would be x to the fifth. All right, if you are dividing the same bases with exponents, then you keep the base and you are going to subtract the exponents. So let's say, for example, we have x to the fifth over x to the third. Right? If you have 5 of those x's on the top and 3 on the bottom, 3 of them are canceling out, leaving you with 2 in x squared. Now, if you have the 0 as the exponent, anything to the 0 power is 1. So let's say you have x to the 0 power. That is going to equal 1. All right, if you are raising an exponent to a power, so this is your power rule, you keep the base and you are going to multiply the exponents. So let's say, for example, you have x to the second and you're raising it to the third. That would be x to the 2 times 3 power, which is 6, x to the 6th power. Now, if the exponent is negative, you rewrite with a positive exponent. And basically, it switches spots. So remember, if you have x to the negative second, that's going to send that into the denominator. That would become an x squared. If your negative exponent is in the denominator to begin with, so let's say you have 1 over x to the negative second, it moves that into the numerator. It becomes its inverse. All right, now as promised, we're putting it all together today. So some of these problems, you're going to need almost all 5 of these rules in. So let's take a look at the first one. I'm going to have you copy it down in your spiral notebook first. So you have the quantity of x to the fourth, y to the negative third, raised to the third, all over x cubed y to the fourth. Now, I would like you to go back and think about the very first thing we covered in this course, and that was order of operations. The order of operations governs everything we do in mathematics. Even at the very highest level of math, we still always actually go back to our order of operations. If you think back to that, parentheses and grouping symbols are the first thing you need to eliminate. Same thing when you're going to simplify a problem like this. So the first thing we want to do is get rid of that exponent of 3 that is outside the upper set of parentheses. In order to do that, you're going to be using your power rule. So each of those exponents inside the parentheses, you're going to multiply by 3. So your new numerator becomes x to the 12th and y to the negative 9th over x cubed and y to the fourth. Now, at this point, very often, some people like to get rid of the negative exponents, and some people like to just use the rules and then simplify at the end. So, let's say we are going to eliminate the negative exponent right away. We have a y to the negative ninth here, right? We know that if that has a negative exponent and is currently in the numerator, that means that term has to go down to the denominator. So if I rewrite this, then that's going to be x to the 12th over x cubed y to the fourth, and then we're going to have a y to the ninth also in the denominator. Let me get my y to the ninth to look a little bit better there. All right, now we can go ahead and simplify. So we have an x to the 12th divided by an x to the third. Keep the base, subtract the exponents, so that would be an x to the ninth, and that would stay on the top. Now, the reason you know it's going to stay on the top in the numerator is because notice you had more x's in the numerator than you did in the denominator, right? So it was top heavy, so it's going to stay on the top. Now, in your denominator, you have y to the fourth times y to the ninth. That's on the same level, so you'll just use your multiplication rule and you'll keep your variable of y and you're going to add those exponents. So you get a y to the 13th. So you get x to the 9th over y to the 13th. All right, number 2. Another problem that's a little bit more complicated. It is very similar to the first one we did, right? So copy this down and go ahead and start by getting rid of this exponent of 2 outside of the parentheses. All right, when you distribute that power of 2 or you use the power rule, you should get 12 squared, which is 144. Then you have m to the fourth, n to the 12th. And then you have this divided by 8m to the fourth, n to the 7th. Now, since you have those constants out front, you want to go ahead and divide them out. So if you take 144 and divide it by 8, that's going to give you 18. Notice the m to the, your m to the fourth and your m to the fourth, those are going to actually divide out. Then you have your n's. You have n to the 12th divided by n to the 5th. It is top heavy, so that means you won't have a denominator in this case. And 12 divided by 7 gives you 5, so you end up with just 18 n to the 5th power. All right, let's move to another multi-step type problem, or multi-rule problem. Number 3, take a moment and copy it down. You have the quantity of 3x to the 5th raised to the 2nd times y cubed all over 2x to the 4th y to the negative 7th. Again, here we need to get rid of that outer exponent of 2 by using the power rule. So each thing inside will be raised to the 2nd power. So 3 squared is 9. X to the 5th raised to the 10th is, or raised to the 2nd is x to the 10th. We have y cubed, then over 2, x to the 4th, y to the negative 7th. Now again, many people like to get rid of their negative exponents right away. That would move up to the numerator because it's a negative exponent in the denominator. So now you have 9 x to the 10th y cubed, and then you would have a y to the 7th that is moving from the denominator. And then left in the denominator is 2x to the 4th. All right, simplifying that. Notice 9 over 2 is not going to reduce, so that's going to stay 9 and a 2 in the denominator. When we look at our x's, you have an x to the 10th divided by an x to the 4th. So that's top heavy, so whatever's left is going to be in the numerator. 10 minus 4 would give you 6. So you have an x to the 6th. And my 6 looks bad. And then your 2 y's, you have a y cubed times a y to the 7th. So you're going to keep the base and add the exponents, and you would get y to the 10th. All right, let's take a look at example 4. In this case, you have the quantity of negative 5x to the 6th times 2x to the negative 4th y times negative 6x to the negative 3rd y to the 4th. Now, in this case, you have several sets of parentheses, but notice that there are no exponents outside of those parentheses. So this is just simply a standard product rule problem, right? Where you're going to multiply your coefficients and then add all the exponents on those like variables. So if we take our negative 5 times 10, or negative 5 times 2, that would be negative 10. Negative 10 times negative 6 is positive 60. Then working with your x's, again, you're keeping the base and you're adding all those exponents. You would have x to the negative 1st. And then with our y's, you have a y and a y to the 4th, and that would give you a y to the 5th. Now, in this particular problem, you don't want to leave any negative exponents in your solutions. So our x to the negative 1st, we know that we could rewrite that as a positive exponent by moving it into the denominator. So we would end up with 60 y to the 5th all over x. All right, let's take a look at example 5. And you know what? I need to erase my lines around. All right, so number 5, the numerator is the quantity of x to the 4th, y to the negative 3rd, raised to the 4th power, and then we have all over x to the 0 and y to the 2nd. Now again, in this case, we have exponents that are outside of the parentheses, so that's going to tell us we need our power rule first. So that would give you x to the 16th and y to the negative 12th. Now, as you go to rewrite the denominator, notice that the first part is x to the 0 power. Well, we know anything to the 0 power is 1. And 1 times y squared would just give us y squared. All right, in this case, we're left with a negative exponent in the numerator. That tells us that that term goes down to the bottom. So we have x to the 16th over y to the 12th and y squared. So our x to the 16th we will leave alone, and in the denominator, because these are like terms and you are multiplying them, you will keep the base and add your exponents. So we get x to the 16th over y to the 14th. All right. In number 6, we're going to multiply two quotients together. And in this particular problem, I have students take all sorts of different approaches. So sometimes students will take each term and separate or simplify it first and then multiply. I normally personally find it easiest to just multiply straight across first and then simplify your quotient. So we're going to kind of take that approach. So if you multiply, remember when we multiply two fractions, we multiply numerator by numerator and denominator by denominator. So if we multiply these two numerators together, 5 times 3 would be 15. X to the 4th times x cubed is x to the 7th. Y cubed times y to the 5th would give us y to the 8th. In the denominator, 8 times 6 is 48. And we have an x to the 5th and a y to the 4th. Now we have a quotient, and all we have to do is look at our quotient to see if we can simplify it. All right, 15 over 48 is a fraction, right? 15 doesn't go into 48 evenly, but we need to think of factors of 15 that may also go into 48. And 3 goes into both 15 and 48. So 3 goes into 15, 5, oops. 3 goes into 15 5 times, and 3 goes into 48 16 times. So 15 48ths would reduce to our 5 16ths. Now, looking at our x's, you have an x to the 7th and an x to the 5th. That divides out nicely. It's top heavy, so your x would be in the numerator. You get an x squared left. And then if you look at your y's, y to the 8th divided by y to the 4th, again it's top heavy, leaving you with y to the 4th. Now, you can write your answer like that. Since there are no variables in the denominator, you may also write your answer as 5 16ths times x squared y to the 4th. Either way that you write your answer is totally fine. It just depends on how you write it, but they both mean the same thing. All right, number 7 looks a lot like number 6. So I want you to go ahead and try this one on your own. So this is going to be one that's you practice on your own. Again, start with multiplying first straight across, and then work on simplifying your answer, your quotient that's left. All right, when you multiplied and reduced, you should get 1/9 x to the 5th y squared, or if you wrote it like I did, 1 x to the 5th y squared all over 9. All right, now number 8 looks crazy. I put it in here because you know what? If you can solve this, I would say that you are a master at exponents. So I'd like you to take a few minutes and try this one, and then we'll be able to check your answers with mine in just a few minutes. I'm going to give you a hint. Start with the fact that outside of your parentheses, you have an exponent. So you have to use the power rule, and in this case, both on the numerator and denominator, in order to get your answer. Now, if you've done the first step of distributing those powers, if you look on the screen, this is what you should have. In the second term, I have all of these pieces that have negative exponents. I'm going to first flip them all. So if they're in the numerator, they're going into the denominator. If they're in the denominator, they're moving up to the numerator. And then from there, we'll worry about multiplying and simplifying. All right, at this point, I did all my flipping with the negative exponents, and I'm ready to multiply across. So 4 times 4 squared would be 4 to the 3rd power, and 4 to the 3rd power is 64. Then I have an x squared and an x to the 8th. That's an x to the 14th. Then we have a y to the 8th, a y squared, and a y to the 4th. So that is going to be a y to the 14th. In the denominator, I have an x squared and an x to the 8th, so that's x to the 10th, and a y to the 4th. And then at this point, I have x's I can divide, and we have y's that we can go ahead and divide. So the 64 would remain in the numerator. X to the 14th divided by x to the 10th is x to the 4th, and then y to the 14th divided by y to the 4th is y to the 10th. Now, like I said, that problem is a bit crazy, but if you're at the point where you can get that one on your own, then I would actually call you a master of the rules of exponents. All right, we are done with the notes for today. I ask that you please log into Google Classroom, do the practice that has been assigned for today. Please try to do it by 11 a.m. because we do look at your work and your answers before we meet at 11:30 a.m. All right, we'll see you in a little bit.